Hi, history of nutrition. Pretty much you can follow the handouts, but I'm just going to hit the high points in this part. You know, references to nutrition began way back. If you started talking about the cavemen, started talking about some of the drawings that they had in the walls, and kind of indicated in this case an incidence of rickets, which is a deficiency in calcium, particularly in young animals. And so you end up with more of a tetanus type deal, offset, bones not forming correctly, not having the same bone density. Scurvy was also one too that, we turned around and the old British sailors were called limeys. And what they were running into when they were on a ship for an extended period of time was basically deficiencies in vitamin C. And so they were having problems with their gums, receding gum lines on it. And so they noticed that when they took limes on these long trips with them, that at that time, it was preventing those issues with their teeth. And so that aspect was a deficiency in vitamin C. Multiple references, if you went back through the Bible, grasses, vitamin A deficiencies, just multiple different parts if we get back into the Old Testament. Now, from a scientist standpoint, and probably one even before Antoine Lavoisier, was Hippocrates, the father of medicine. And you may want to add him in as one to make sure you know for the quiz. But way back around, I guess probably the turn of the previous century on it, around, probably 0 BC was when Hippocrates was around. And he noted then that the stomach was a melting pot. And we worked on up, and Sanctatorius was actually slightly before Lavoisier, and he understood at that time that they made a weight chair, and they wondered where that actually went and why the weight was going away even after a consumption. And so from a measurement standpoint to determine it. So Antoine Lavoisier was one of the first there to kind of sit and determine, and basically known as the father of nutrition. Von Liebig, not as concerned with, father of agriculture and agricultural chemistry, our experiment stations that we have. Kjeldahl's nitrogen determination, and you can see the apparatus there. It was a long, slow process that we've really simplified now, basically with modern technology. And so we even get down to specific amino acids and amino acid concentrations that are in there. Fisher as well was the first one to determine that proteins were composed of amino acids. Atwater is one that you need to know, as well as the equation for respiration. Simple, it should be old biology 101, C6H12O6 or glucose or some of the other isomers of glucose, plus oxygen, and that's for animals. We yield CO2, H2O plus energy, and in our case, ATP. Flip side of that was you take that CO2 in the presence of water and sunlight, and a plant was able to go the opposite way and turn around and yield cellulose, C6H12O6, plus provide oxygen for us. So Atwater's deal as well, first analysis of an ingredient, and that ingredient was our most common feed stuff that we use in livestock diets, which is corn. First food composition table, and basically that goes into how much protein, how much carbohydrates, where we look at the back of a food label and it has our recommended daily allowance. Also, it'll tell us exactly how much carbs are in it, and a lot more of those details. Now, Funk was one of the first there as well. Beriberi was a deficiency in thiamine, a vitamin B1. And so at that time, there was a lot of processes towards the end of the 1800s, beginning of the 1900s, that were coming in and discovering vitamins. So, other one too that you need to know is Robert Malthus. And what he said at the time, back in the 1400s, that the world population was going to increase exponentially, whereas food production was only going to increase linearly or arithmetically. And so what we've done for food production, as we discussed in class, is Hey, that big header on a combine now, when they're harvesting rice, harvesting beans, is probably 4 times the size that it was even 30 years ago. And so if we had followed what Robert Malthus had said, our population would have starved. As it is, though, we've been able to keep up and maintain. If you go to the World Population Clock, you'll be able to see exactly where we're looking. And the biggest thing with that, we're talking about a population here by the year 2050 that's going to be over 9 billion. And so that's quite a big increase there. So we're going to have to maintain that from a modern aspect for us to be able to feed that population. So modern nutrition, and as we talked about, we've got some machines now with more of a digital type thing. We can use spectrophotometers. We can get way more detailed than we used to be in terms of our models and what we determined. Our actual recommended daily allowance right here, very similar to a diet. And so we'll talk about later in the semester how many there for 2,000 calorie diet, a 2,500 calorie diet. Calories per gram at the bottom. I'm not sure if you can see, but had fat at 9, carbohydrates at 4, and protein at 4. Those were your physiological fuel values that Atwater helped determine back before. So we're looking at an RDA here. Recommended daily allowance for people will be very similar to what we talk about in a daily diet for animals.